Hello, hello. Okay, my name is Pranav Surampudi, and this is a demo lecture on cloud computing. Uh, I'll be talking about distributed systems and uh, virtualization in this lecture, and how these two technologies are uh, very pretty important when it comes to cloud computing, as they form uh, a backbone of the major cloud providers. All right. Okay. Uh, Jumping right ahead. Let's see. I'll be using only some of these slides. For the remainder of this presentation, I'll be just talking throughout this lecture. And yes, I'll show you some slides as well, maybe couple, not more than that. And this will be a very short presentation, maybe 20-30 minutes tops. Okay, so what is cloud? So you can see the definition on the slide that I'm showing you right now. You can read that definition. But personally, I would define cloud as a bunch of machines connected over the internet, whose resources can be shared by many users. So you have uh, a quota when it comes to cloud. So you have this vast array of servers that are present inside the data centers of large companies like Google, Amazon, Microsoft, DigitalOcean. There are several cloud companies. All right. So there are these huge machines, servers that are present inside the data centers of these companies, and you can actually get access to those machines, and you can run workloads on top of them. When I say workloads, I mean applications on top of that. Like, for suppose, if you want to run your own email service, you can use Gmail, right? You are using Gmail, right? Gmail is actually hosted on Google's cloud platform. Got it? Similarly, if you want to start your own video streaming service, or a game, you want to stream gameplay, you have companies like Twitch and YouTube, right? They too run off of public cloud infrastructure, and sometimes their own private infrastructure as well. So when I talk about cloud, there is actually three different types of clouds. Broadly speaking, there are many categories as such when it comes to cloud, but there are three categories. One is public cloud, the other is private cloud, and the third type of cloud is hybrid cloud. So you might be wondering, what is the difference between public cloud, private cloud, and hybrid cloud? Well, let me tell you. Public cloud is a type of cloud computing platform where the general public, meaning you, me, and anybody who wants to develop applications and deploy them on the servers, get access to those servers and the underlying software with cloud providers like Google, right, and Amazon. Yeah, as I was saying, public cloud platform is basically an free, open for everybody type of deal, where you can use all types of workloads and applications and infrastructure that is available to you, that is made available to you, and you actually pay as you use that. That is the main feature of public cloud. Private cloud, on the other hand, means that if you are a large corporation and you want your own cloud network, and you want your own specific type of infrastructure to be set up globally, so that you, meaning that only you as a company can make use of those things, that is a private cloud. For example, companies like IBM, Oracle, Dell, BMW have their own data centers for their own use, internal use. So they are private clouds. They are not exposed to general public like you and me. They are mainly meant for enterprises to run their own applications as such. And the third type of cloud is hybrid cloud, which is a combination of both public and private cloud. Think of this scenario to understand hybrid cloud. Say you have your computer, right? You have connected it to the internet, but you want some place to back your data up so that in case of data loss, you can recover your data and restore your machine to a particular point. In such case, you'll store all your data on a cloud or on a hard drive, right? So imagine the same thing, but for enterprises, meaning that, so sorry, a certain portion of your cloud infrastructure will be hosted by you, meaning that section of the cloud will be private, and you will be paying for that, and you will be in charge of what type of infrastructure and what type of networks and what type of software you run on top of your cloud. And also you get access to some public cloud resources, right? It's a mix and match of both worlds. So that for applications that require your specific criteria, you can use your private cloud, and for general purpose things you can make use of the public cloud. So that gives you the advantage of the both worlds. But the issue is that you have to maintain both your public, you have to maintain your private cloud. The issue with private cloud and hybrid cloud is the private component of the cloud is to be maintained by you, meaning that you have to hire people to take care of the network, take care of the operating system, firewall, security, etc., etc. But the when it comes to public cloud, all that is taken care of by the cloud provider itself, and you will be actually paying for that as well. So it comes as a one single cost, but that actually includes costs such as maintenance costs, network cost, operating systems, applications, manpower, labor, so on and so forth. You will be paying for all of that as well. In private cloud, you will be paying for the physical infrastructure as well as you will be paying people to maintain that. So private cloud is usually on the pricey side, but nevertheless. You always have the option to go with public cloud. Okay, this is a brief summary of how cloud is going to look like. Okay, okay, PaaS, SaaS, IaaS. What are those three? Even these three are types. Okay, those three are the types when it comes to a public cloud provider. All right, those three are abstractions on the type of services that a cloud provider might provide you. Okay, I'll talk about those as well. Okay, what is PaaS? PaaS stands for Platform as a Service. Platform as a Service means that you'll get access to a wide array of applications and a wide array of resources that you can use to build something else, right? For example, if you are trying to build a website and host it on AWS or GCP or any cloud providers, you just get the resources that are necessary for you to build and host that website. The onus is on you to build that website, write the code for that, and then take that code and deploy on a particular server. But that is platform as a service, meaning that you get access to uh, a combination of both hardware and software related stuff. But usually the hardware related stuff is actually abstracted away from you, but all you get is think of it as a dashboard that has a lot of applications and little widgets that you can use to build your own applications such as web servers or games or whatever might be, Android application backend, whatever that your use case might be. You will get access to software that will actually enable you to do that. That is platform as a service. Okay, you have an idea on those three. Do you also know what SAS and IAS also mean? Yeah, I'll take a pause right now. Okay, fine. Then I'll move on and I'll talk about distributed systems and virtualization and how it actually helps cloud, and maybe we'll conclude the lecture and have a Q&A if you have any questions further down the road. All right. In this slide, just look at the second point: history of deployment. When I say deployment, it means that you have already written code for an application and you want to put that code onto a server so that your company or you yourself can use that either as a backend or front end or a combination of both. It can be anything. It usually depends on the use case that you are trying to achieve, accomplish, or rather accomplish. So yeah, there are three types of deployment. So actually, this is the chronological order. Previously, people actually used to own physical infrastructure, meaning companies actually used to have servers and server rooms within their organization, or they used to buy compute from data centers. When I say compute, it means that they used to buy physical servers and compute time from data centers so that they could the, deploy their applications and make it available to the users. That was during the 90s and early 2000s. Then came VMs. I'll talk about VMs in a bit, but VMs actually stand for virtual machines, where instead of the physical server, you actually partition the physical server into logical blocks called virtual machines, each with a specific set of resources, meaning that each VM has a certain amount of CPU, a certain amount of CPU cores dedicated to it, certain amount of RAM dedicated to it, so that, and certain amount of network bandwidth and storage as well. So one thing you have to remember when talking about cloud is all these things actually put together make the cloud: the CPU, the memory, the network bandwidth, and the storage. All these things put together, basically these four things supplement you when, as a developer, when you're trying to deploy an application. So all these four things are put together, and they're the hardware on which the actual VMs run is actually abstracted away from you in virtualization. So you'll be getting a virtual machine when you actually go to any public cloud provider and request for compute. You'll not actually have access to a physical server, but instead you'll have access to a virtual machine on which you can schedule and run your workloads, right? Yeah, and the third one is containers. This is a very actually Google has been using containers since 2003, but containers have been in the mainstream only since maybe 2010 or so. But for the scope of this lecture, we'll omit containers as such, and we'll talk about virtualization. All right, I'll just pull up the next slide. Yeah, so this is how virtualization looks. This is a picture that represents a typical server side virtual machine setup in most of the public cloud platforms. It might not be this simple. They might have a lot of tooling around this structure to let you see what you see, but This is what in the very base level of VMs, this is what actually it looks like. So will come from bottom up. So when I say infrastructure, this means the physical server on which your VMs are actually located. And hypervisor, moving on to the next layer, hypervisor is a piece of software that actually controls your virtual machines. If any instruction has to be executed by the virtual machine, it goes to the hypervisor, which in turn executes that instruction on the physical CPU on which these virtual machines are hosted. Um, think of it like this. It's like an apartment which has a lot of flats, right? The flats are jointly owned by all of the people that are present in that apartment, but still they have some common areas, right? It's like that. You have your own virtual machine that which has the specs that you have requested, this much amount of CPU, this much amount of RAM that you have requested, but that infrastructure isn't specific to you. If you know what I mean, it means that uh, yeah, think of it this way. I've even got a better example. For suppose this physical infrastructure has 32 cores and 120 GB of RAM. That is the physical server size of the server if you are talking about. But you require only 8 cores of CPU and 16 GB of RAM. So you can provision a virtual machine out of this 32 and 120. Out of this 32 cores and 120 GB of RAM, your 8 cores and 16 GB will be provisioned into one virtual machine, which you can use to do whatever applications you want to run or databases you want to run on that. You can use it. For example, if I want another machine with remaining 24 cores and some 100 GB of RAM, since your quota minus the existing one still can accommodate the request that I want, I can also run the my own virtual machine on top of the same physical infrastructure, but we will both will be isolated from each other, meaning that whatever applications you are running, I'll not able to see that. I'll not be able to see that. Similarly, whatever applications you are running, I'll not able to see them. It cuts both ways. So you're using software, you are actually abstracted from each other, even though we are running our applications on the same physical server. We are abstracted by software with the help of virtual machines. So this is just one facet of how VMs look like. So just imagine this, but with thousands and millions of servers, each capable of handling hundreds and thousands of VMs. So that's what is the scale of distributed systems is. So instead of running applications on a single server and blocking it for only your use, you are actually spreading the load across many physical servers by making use of something called virtualization. So that is the scope of distributed systems actually. Instead of processing data on one physical server that may or may not utilize the 100% of the physical infrastructure on which it is hosted on, instead you partition it onto demand based things called virtual machines, and you will only use whatever is allocated to you. If you exceed that quota, your virtual machine will be killed. So it will not be descheduled or it will not disconnect or anything. It's just that it will just go out of memory. It will be out of memory, and then you can schedule that into another virtual machine with more amount of RAM. So that's the facility that you have. And another big plus of virtual machines is, for suppose if you are running a big website like Flipkart or Amazon, and you are about to host something like a big billion day, where millions, hundreds and millions of users uh, have access to the your website, and they might be placing many orders. You can actually spin up millions and millions of virtual machines on top of this physical infrastructure. so that they can your web servers can handle those loads, and they can work properly without crashing, right? All right, let me just take a little pause. Okay, you don't need to have any coding knowledge for Azure or AWS or GCP. You don't have to have any coding knowledge for that. But if you want to develop deploy applications onto the uh, cloud platform, yes, then you have to have a little bit of coding knowledge. But I'll be mainly focusing on the types of services that Azure or AWS. I'll be mainly talking about AWS when it comes to this course, because that is what I'm more familiar with. I'll be talking about various services inside the cloud computing platform of AWS that you can use to do a lot of cool things, whether it be ML or whether it be uh, data processing with something like a MapReduce module of AWS. I'll be talking about mostly the services that are offered by AWS and how this internally these services and softwares work. So yeah, if you want to develop applications for the cloud, yeah, coding knowledge is necessary. You need to know how to write a code for web servers in something like Node.js or Python or Golang or something on those lines. You need to know how to write code for that. But I'll not be talking mm, a lot about how to write applications for cloud. This course is mainly meant for people, uh, you know, those who have a little bit of experience in coding, and they want to make use of the cloud infrastructure to deploy their applications onto the cloud, and also make use of several fun things that AWS has to offer in their wide suite of applications that they have. So yeah, to answer your question, if you are familiar with web server development, this course will make much sense to you. Personally, I don't think I'll be talking much about how to write code and deploy applications on top of that. Yeah, I think I'm mostly done with what I wanted to say. If you have any further doubts, I'll keep this chat open for a few minutes. You can post your questions if you have any. Yeah. Okay, Rohit. So I'll end this demo lecture now. Feel free to contact me on WhatsApp if you're interested in taking up this course. All right. Thank you. Thank you for listening. Bye.